Hi, this is Mr. Miller and welcome to a new math video. In this video, we're going to talk about how to find the intervals where a function is positive and negative. So we have just a couple examples here. So we have a graph of a function given here below, a nice purple function. And the instructions are to find the x-intercepts and identify the intervals where the function is positive and where the function is negative. Okay, so we can do that. Before we start doing that, though, I just want to comment on what these arrows down here at the ends of the function mean. So on the left here, this arrow means that this function kind of goes down forever and to the left forever. We'll kind of need to think about that in a second. And this one over here is kind of going down, but towards the right. The function goes down forever and to the right forever on this end. Okay, so let's start answering what they want. So the first thing is they want us to find the x-intercepts. So these are points, and they're points where the graph crosses the x-axis. Okay, so over here we see that one of them is at -4, 0, and the other one here is at 2, 0. And they're not always going to be nice numbers like that. Sometimes they may have decimals. So sometimes you'll graph functions in decimals. You can click on the point and it'll give you like a decimal for the coordinates. That's okay. But these worked out kind of nice. Now, these x-intercepts are points where the function is actually equal to 0. The y-coordinates of these points, which is the output of the function, is 0. We notice that in between these, the function is positive. For instance, if I take a point here like x equals -2, and I said, what's the value of the function there? We would go up and read off the y-coordinate. We see that the value is 4. It's positive. Same thing with like this point here. If I go here, at x equals 1, go up to the graph. We get a number that's a little bit bigger than 2. All right, so it turns out the values of x where the function is above the x-axis is where it's positive. So this part of the function right here in between the intercepts, that's where the function is positive. So the interval where it's positive, well, it starts at -4 where that intercept is, and it goes up to 2 where this other intercept is, and we're going to put a curved parentheses around this because the function is positive in between these points, but not actually at the points themselves. Okay? Find the intervals where the function is negative. Well, that's kind of everywhere else. So we see over here, like at -5, if I ask you the value of the function, it's below the x-axis, and the y-coordinate is negative. So for these x values over here, up to the intercept, the value of the function is negative. So we can say way out from -infinity, because this function, remember, it keeps going to the left and down forever. So from -infinity up to -4, that intercept, the function is negative. Okay? But it's also negative for these values. It goes up and it dips below the x-axis there. So values of x where the function is below the x-axis is where it's negative. So this interval starts at 2 and goes to positive infinity. It goes to the right forever. Everywhere to the right, the function is below the x-axis. Now we have two intervals, and so we're going to put a union sign in between these. That means where's the function negative? Anywhere in this interval or in that interval. Okay. All right, that's basically everything. So we're going to practice this again a little bit here. It says find the x-intercepts. Well, we have one here, one there, and we have another intercept there. So I'm going to list them as points. We have 0, 0. We have 2, 0. And we have 4, 0. All right, find the intervals where the function is positive. Okay, it's like, where is it above the x-axis? So right here, for these values of x, the function is above the x-axis. The y values are positive. So we have from 0 to 2, but also from this point onward, it's above the x-axis. So union 4 to infinity. For any point value of x in that region, the function is above the x-axis. All right, well, kind of everything else is where it's negative. So from negative infinity up to that first intercept, the function is below the x-axis, and then we got another piece in between these values of x. The function is below the x-axis. So from 2 to 4. All right, so again, we're looking for intervals of x values where the function is above or below the x-axis. All right, so this is not too bad. This one has a little something to it, though, a little trick here. So we're going to find the intercepts. It crosses the x-axis here, so that's an intercept. But so is this. An intercept is where the function's equal to 0. And even though it doesn't cross here, it touches the x-axis there, and that's an x-intercept. So we're going to put negative 2, 0, that's the first point, and then we're going to put 3 comma 0. These are not intervals, so I'm not putting a union sign in between them. It's just 2 points that I'm listing. All right, find the intervals where the function's positive. Okay, this is a little tricky too. It's positive from there to there. So from negative 2 up to 3, it's actually not positive at 3. It's 0 there. But then it goes back, turns back, and is positive again here. That's kind of crazy. So in essence, we're just leaving out 3. We're going from negative 2 to 3, but not including 3. And then from 3 to infinity, again, not including 3. We kind of just left out that point. That's the only point in this area where it's not positive. Okay, now, where is it negative? Just over here, from negative infinity up to that point. So from negative infinity up to negative 2. Notice we've kind of covered the whole x-axis. Either the function is 0 and it's an intercept, or it's positive and it's above the x-axis, or it's negative and below. It's got to be one of those 3 things. So pretty much our answer covered the whole x-axis. All right, good luck with this topic.